Right? We're talking about internal assessment. Standard labs are an X. So what you can do is standard lab. Let's get green here for go. With a twist. Now, what is that twist? You have to show, and it's one of the criteria that you're being graded on, is personal engagement. So you're graded on your personal engagement. And that's demonstrated by how you write about it. One of the horrible examples that they gave teachers to look at was the comment, "I love physics," and that was highlighted, and the markers commented, "Well done for personal engagement." Yeah, that's crap. Okay, so you can't just say that. Okay, so they're looking for real personal engagement, even though the sample they gave was horrible. A great example of personal engagement was Denny with basketball. Denny loves basketball, so he brought in his knowledge about some free-throw shooter and talked about height, and obviously he cares about basketball, and he designed a lab about basketball. Okay. Suraj, he loved oscillations and damping, right? Simple harmonic motion. He loved it. Okay. And so one thing I suggested to him was some of the doors downstairs, like the red ones, would go. I had some nice examples of simple harmonic motion and damping for the big red doors. He instead made instead of just a spring oscillating up and down, which would be standard and bad, he took a beaker and he had weights going either in and out of the water, and he changed the weights, or maybe he even changed the amount of salt in the water to change the density of it, and he investigated that way. So it wasn't just a standard lab of a spring going up and down. He had a twist. Then he was his basketball completely original. Again, one boy, he rushed in. He did something with the track. Right, you know, my tracks in the cars. He did something. He collected data. Took him like 2 hours, and then he forgot key things. He didn't know how to process it, or he's missing a number. He didn't record this other number towards, or he didn't control his variable properly. So that was wasted. Then he did another lab, and that was wasted. Then he did a third lab. And so he spent lots of time after school. So please rush in, don't. So take your time and plan properly. What you want to do is know how you're going to, what's the word, your data? Process. Process your data. Don't just say, I'm going to collect this and I'm going to find this number. But actually, maybe try it once and actually process the data to see if you can start working towards that. Or say, oh, if I had a graph of this, I could do this. But don't just say, yeah, I'll just graph it and then I'll find this thing. Well, the boy couldn't do it. And it took him 3 different labs. And instead, and what confused me is instead of just doing the first lab again and fixing it, he said, nah, I'll do something new. And he did that 3 times. Okay. But at the end, he did well. He did okay. Yeah, better than okay. So people looked at different things. So does that answer your question, Angela, for things that we've seen? Okay. Again, with the tracks, can you think, oh, can I just do a Newton's law with the track? I have a track, I have the car, I have weights. Can I just change the masses? Of course not. But could you add a twist to this? So with the twist is sometimes the hard bit. Okay? So how about we right now, we take this basic lab, and you guys take out a piece of paper, and I want you to think, what are some different twists that you can do? Not that you're necessarily going to do this lab, but start thinking of things. Okay, here's the equipment we have. What's something that I could do with it? What is something I could do with it? Does everybody understand? Minami doesn't. Do you understand my horrible picture, Minami? No, come to the back. If you don't understand my horrible picture, come to the back, please. Minami, you were here in grade 9. Oh my goodness. Here we got the ramp. We have the car. Now, we pretend spring here, Minami, and a pulley, and the mass is full. When it falls, it goes like this. Does that make sense? If you have a little mass, if you have a heavy mass, it goes fast. Does that make sense? So that's what my horrible picture is. Okay? Your internal assessment can either be inside, like those that we've done in class, or it can be anything that you would like to investigate about physics that is outside. Maybe we haven't studied it yet, or maybe it's not in the syllabus at all. Okay, it could be something that, for some reason, right, the IB says we have 240 hours, and it's not here, because that would take 243 hours if they put it in. So it's physics that could be here that's not. Okay, so it doesn't have to be something inside here. It can be beyond the syllabus. So we have a car with these weights. Okay? And the standard lab is to either put more masses on top of the car to make it heavier, or put more masses on here to make it accelerate faster. Right? Because we have acceleration equals F over m, and we change one of those two things. Now I'm going to give you about 5 minutes because you have to think about this. Think about things when you talk with your neighbor. What are some things that you could do to make this be different than the standard lab? What are some things that you could do that would be different than the standard lab? Mm-hmm. So I'm going to sit, relax, and take a bite of this. Maybe this muffin. And draw various ideas, write down the independent variable. So you're kind of rushing catapulting this, but you're changing it. You're making it unique. You're making, as far as you know, never been done before. Even though this is a pretty standard lab. You're going to make it non-standard. Here's what I thought of as I was drinking my water. Submerge it in water. I don't know. How does it go there? Because you can have friction of the water. Yes.
You could also place it in different paths, like.
This way, I want more people to think, talk with your neighbor, and then we'll have a bunch more feedback. I think people are still not getting a single idea. So you've got one. So get a few different ideas. How could you make this be non-standard?
아 아니면 여기가 프레셔를
아니 프레셔를
지금 여기다가 석수기를 다
공기적으로 그때가 지금 그거 아니에요.
에어를 리스턴스를 느끼는
내가 수도가 아니라 넣어가지고 그냥 치면 돼요. 수도가에 넣지 비용치를 하고 소포에 들어 그러니까
그리고 각도를 주는
중력이 얼마나 차이가 순수한 중력
진짜 어렵다.
우리가 얘기하면 다행이야.
아니면 진짜 마음이
말이 많아서 회전하고 회전하고 이거 있잖아.
아니면 전기를 연결하고
전기를
내가 길을
이겼어요. 그럼 이 엑셀을 전기를 넣어가지고 얘가 밑으로 꿀잼인데 얘가 이렇게 움직이잖아.
We have an oscilloscope. Yes, we do.
이렇게 움직이면 이렇게
빨리 이거 할 거야. 아니면 이렇게 내려가서 이렇게 운동을 지는 거야. 몇 시간 됐어? 딱 내려가자마자 밖에 운동을 되는 거야. 그러면 MC가 그러면 온도가 다르니까 온도가 에너지 측정하는 거야. 이게 따로 내는 측정이야. 그러면 프렉션은 얼마나 나가는지, 얼마나 나가는지, 포텐셜이 얼마나 체중이 줄어드는지
너무 에너지가 크잖아.
왜 자꾸
이걸 쓸 수 있다면 이걸 쓸 수 있다고. 공기 무슨
무슨 위치야?
좀 빛으로 가정했을 때 저 빛으로 나오는 게 불도잖아. 괜찮은데?
Okay. Now, people might do various things, so please come up, unfortunately, Ryan, to the regular whiteboard. And I think you want to draw something totally different, or can we just add it to my picture? Oh, okay, I'll take that as my picture. Okay, Jose, you had an idea. What was your idea again?
Should I go?
Well, should you draw it, or can you tell me, or what's better?
I can do both.
Okay, we'll draw on that one, I think. Okay, well, Jose's drawing. Do you want to talk as you draw?
Yeah, sure.
Okay.
So, for example, here's the path, like the track. Or it,
Oh, actually, come here for Ryan. Come here for Ryan.
okay.
It's kind of yucky, but Ryan, we care about you, buddy.
So I'll just draw on top. Is that okay?
Yeah, or draw my messy one, whatever you want.
So basically, I wanted to have the path here, but like instead of having just the track as a path, have a
Yep.
different path. So like for example, this could be the track, or this could be like the track with sand as well, or we have a different path of a different material, and instead of testing the changing the mass, we change the friction depending on each path. To and maybe like that way we can do something about friction and doing so.
Okay, good. Now you talk about changing the friction. Now let's go back to Mr. Fleming. How many numbers do you need, Jose?
8.
8. So you have to get 8 numbers. Can you write sand on your... Can you make a bar graph of sand on it? Will a bar graph work in physics?
Bar graph? No.
No.
We need a line graph.
Need a line graph. So again, quite often people get the ideas of switching substances. Whenever you get that idea, here's my tip. Find, no, Jose, because your idea is good. Okay. Find the coolest one or the one that you think will work the best. And instead of changing 8 different substances, choose one of the 8, then change the amount of it. So maybe, Jose, let's say sand's a good one. You might put on here 1 millimeter of sand, or a certain volume of sand, evenly spread. Then you put on more sand, and more sand. How many heights of sand will you have?
8.
8. So instead of having 8 different materials, pick one of them and change it. Or pick concentrations, right? Grade 10s, they wanted to do, let's say for their heat, no, grade 9s, sorry, for heat. Someone would do ice cubes and make 8 different substances of ice cubes. Have a Coke ice cube, have a milk ice cube, have a yogurt ice cube, and time them to melt. I said, we need a line graph. So instead, one girl, she did, I think, milk powder or milk, and she had different concentrations of milk. Right, so 10% milk versus the water, 20%, 30%, and so she increased the amount of milk. And then she timed how long it took the ice cube to melt. So it doesn't have to be something big, giant, and hard. Okay? But you do need some kind of twist, so you thought of changing the substance. We'll pick one of them and vary the amount of the substance. That's my tip for you guys. Okay? Any other ideas? Steven?
I was considering maybe angling the track and then sort of look at it in terms of vectors.
Ah!
Some mathematics into it.
Okay. Good. So you have that. Then you have this. Then you have this, right? You angle the track.
Yeah, and then I sort of work with mathematics vectors.
Okay. And this is the other thing. So you have the twist. And what you also try and do is you link your, especially if it's something that's more, well, let's say the physics that we understand quite easily. Okay, there might be a bunch of math there, but you should be able to get a value. So you link to theory, and this is now where you could make a spreadsheet of once you put in the formula, you could say what the answer for 10 degrees, 20 degrees, 30 degrees could be, right? So you'd also make a spreadsheet model. And you would do the experiment, and you get all your data as normal. So let's say you get your data and you get some line or something. Then you say what theoretically it should be, and instead you get that. And you compare them. So you compare. So you do the experiment, and then if you can also just do the math of what it should be, you do that math, and you compare them. So it's more work than a standard lab, right? You get, let's say, quote, 10 hours of class time. Okay, maybe you get 9 now because we took this hour. Who knows? Okay. But you'll get an amount of class time, and you'll probably need more than that. The good news in physics, once you're set up, physics is normally quicker to do. Chemistry, who's a chemistry person here? Lots of you, right? Who's chemistry? Okay, now my tip for the chemistry people. Get started right away. Do you remember your brother? How long he was in there, Mr. McBride? Do you remember? He'd be in here at Chinese New Year and everything. All right, hours. Chemistry takes longer, doesn't it? You're waiting for things, you're making your chemicals, waiting for mixtures to happen and reactions and who knows what.
That was physics and chemistry.
Maybe that's it. Anyways, chemistry always takes longer. Chemistry always takes longer. So quite often takes longer. Physics is longer to set up. Once you're set up, you should be able to do it nicely. So link to spreadsheet theory, make a model. You compare them. Okay? And again, that shows your personal engagement. Other ideas? Steven?
Mr. Fleming, if
Yeah.
you're typing up the personal engagement paragraph,
Yeah.
talk from first person.
Ooh. Well, next year, I imagine you're going to go to this. Anyone seen IB Write? I imagine next year you guys would go to ibwrite.com. And this is where you can thank Mr. Mello. Mr. Mello wanted to make, maybe it's not ibwrite.com. IB Write Lab Report. I'll just do a search instead. Actually, I'll just search. Where's my little guy? IB Write. Maybe this one. Oh, .net. Oh, okay. And you can come in here. You can put your work. I present my grade 9s. And you can write your lab report in here. It has a little guidance. Let me try to click on one. Actually, I'll log off. I'll sign in as a student. Student access. Let's try this one. Log off. Student access. I'm a student. Okay, so you can come in here and let's say background information. Relevance. So you write it, how is this relevant? What's your main idea? Main idea. There'll be little notes and things. I'll give you examples of what to write. And then you're going to see a familiar face. It's not Mr. Mello. If it loads.
This section.
Oh, it is Mr. Mello because I'm in the bio. Sorry. In the physics section, you're going to see my face.
And the effort you
And so each
demonstrate your personal engagement. Relevance relates.
okay. So there is guidance for the new criteria and how to write things in here. So conclusion, again, what's needed, your hypothesis, you write in things, there's guidance, there's how-to references, how you're being graded is all here. So something that Mr. Mello came up with that he turned it into online, and schools around the world are subscribing to it. And then he gets some money, and eventually I'll get some money too. Okay, well, unfortunately, there's less physics students in the world. There's more biology students. And Miss Hansen did the chemistry. So if you're in the chemistry one, and you can sign up possibly, and you'll see Miss Hansen. Okay. Let's go back to the syllabus, though. Did I close the syllabus?
You have to pay for it.
The school will pay. Either Mr. Mello might give it to the school for free, or the school will pay. Does that make sense? But other schools around the world pay for it. Yes. Okay, page. What's this way? Oh, okay. Other comments, questions? Anyone have some ideas now, maybe? In the last few minutes. Angela.
So changing, like dropping the masses into a non-Newtonian fluid and changing the concentration.
Ah, there you go. So very original. And then think about what you would measure and how you'd measure it.
Maybe the time it takes for it to drop to the bottom.
Ah, because it hits and then go to the bottom. Okay. And so again, that's data, that's original. You graph that. You would do some research. Maybe there's information on non-Newtonian that. Again, the beautiful thing is, it's pretty easy to do, isn't it? Right? You get a bucket. You mix some water, not glass, because your weights might smash the beaker at the bottom. And you drop. You time it. How you don't get the bottom? Maybe it hits. Maybe it's too slow. Who knows? But right. All right, so again, lock that one in. That's worth definitely trying. Darren has an idea. Then Jose maybe.
Factors that affect the surface tension of water. Looking at how magnets can change that.
So magnets do magnets change the surface tension of water? Maybe. I don't know. Okay, but again, so think about what you're going to do. And again, my big advice, remember you guys did your open design labs? What did I say when you had your idea?
Check if it actually works.
Go try it to make sure it works. And then that's where some people, right, they're all sneaky and they think, let's collect all my data now. All right, I had a grade 9 boy did that this year. He went to the pool to check his idea that works. And then he came back and said, I'm done. And he had no method or anything. And it was okay, but he could have did a lot more with it. Could have did something better with it. But he just rushed in. So take your idea and make sure it works. Jose.
I was thinking like to test the oscillation time in a pendulum, but like I keep everything constant, like including the size of the ball. Like I get a ping pong ball and fill, like I get different ping pong balls, fill them with sand, like of different masses.
Yeah.
And then see if the change in mass, even though like the circumference and diameter is the same, like if the change in mass, how it affects the pendulum oscillation time.
Okay. What we didn't do this year, did we do the pendulum?
Yeah.
And you guys did back and forth 10 oscillations? Okay. What I used to do is I used to make students design 2 labs, and one lab was about the mass. And what they found out was their graph looks like that. Because our formula is that, and there's no mass in the formula. That being said, maybe it swings and oscillates. Okay, but so you're going to try things out, but also think about your theory. So there's no mass there. Maybe it affects it, but I would say pendulum. If you're going pendulum, go like a dual pendulum. You know how you're seeing them like 2 things like a gear or something?
Oh yeah.
And they'll spin around a lot crazier. And that could be too wild to investigate. You'd have to be actually quite controlled because it might just go crazy. But perhaps consider something like that. Okay, so pendulums. Any other ideas? Other ideas. Manami, any ideas? Maybe musical, piano. Any ideas? The length of something. Okay. If you don't know yet, that's okay. Okay. But sometimes people are very quiet in this class, so I'm going to call them out. Jonathan, do you have any ideas? I saw you had something up on your screen earlier. Was that for this or something different?
I thought they maybe I could look at might be a bit simple, but maybe I could look at the speed of a ball rolling down the ramp.
Ah, good. It's not too simple, Jonathan. I had a little diagram there. Okay. Now, whenever was it last year? Yes, I had a PYP teacher ask me about. They wanted to demonstrate they're doing forces of motion, kind of grade 3. Yes, grade 3, and they wanted to have things rolling down hills. That does not obey our regular physics that we know. When things are on hills, basically all the physics that we know is for sliding down. And yes, we have a car with a little wheel. Basically, that's a car sliding down a hill with no friction. If you have a solid mass and a can, they will roll down the hill differently. Rolling downhill, physics can. Let's see what happens. Hopefully it's appropriate. Oh, good. I wanted to talk about this too. Oh well. Let's just watch the beginning of this one. We're not going to watch it all. Because here's something else that you can do with the modeling. You can do an
Alright,
experiment.
welcome to this video. In this video, I'm going to find the acceleration of an object rolling down an inclined plane. So this is going to involve a little bit more math than
Oh, this guy's quiet. Okay, because there's something called a torque. Okay, especially if things are hollow and not, and maybe you can change the thickness of the outside. So you can make up simulations and compare. Oh, Mr. Fleming, what could I use to make these simulations? Algodo, maybe? Yeah, that's it. Okay, for the iPad, for your computer, you can download it, and you can build all kinds of things in here. And so again, it's real. Yeah, as I say, it's realist physics in here. Again, it's simulation, but you can try things in here, and this is a very open-ended simulation where you can build anything. Okay, so Algodo is one thing I would recommend. Okay. Other comments, questions? So rolling down a hill is good, especially thinking about a solid mass or whether it's a hollow mass. Is the mass more in the center? So also you could have something like this, big heavy mass in the center, and like spokes would be changed. So maybe you could change the mass. There's different things that you could change. Personal engagement.
Mr. Fleming?
Yep.
Oh, remember that thing you showed where you put sand on a certain plate and then it made shapes?
Yes.
Vibrations? Would there be some possible idea I can make from that?
With that, because I know you're a sound guy, with that, I would probably say no, because it's just basically a demonstration. But what you could do, did I show you guys when we had standing waves and we actually saw the waves on here, right? We have a whole kit there because we're having these conversations and we have a few more minutes left. We have various types of wire in there with different thicknesses because that affects it. You can have tension on there that affects it. I got the elastic guide that affects it. So something like this. You can do the actual plate and the thing. That's more to see, I think. Or maybe I guess maybe on the designs, maybe you measure things.
Yeah, like maybe, alright, if I have this earth, how big is the...
Yeah, you can measure. You can maybe measure the radius from node to node. Yeah. So
how many
maybe
spokes it's got?
how many spokes it's got. So you can try different things. Try different things. Okay. But again, what sometimes people get stuck on is they come with an idea which is this a standard lab, and that's too easy. Sometimes you come with ideas which you know are too easy. So what you then need to do is say, oh, how can I give this a twist? How can I change it? How can I make it unique? Maybe I can do this and compare it to a model. Or I do this and then I compare it to something else. So you have your personal engagement. Okay. Then you explore. So you actually will be going and doing research and finding out about your idea. You will then analyze your data. You will evaluate your results and the accepted scientific context. So again, that goes back to the theory. Again, Stephen's idea of changing the ramp and comparing to a theory. And then how well you communicate. This is only 4 points, yes. Again, there's a page limit. Not a word limit, a page limit.
That means you can make the font like this. Or you could just make
No, for you guys, they were very vague and they didn't have good rules. But for next year, they'll have better rules. They'll have a double-spaced, a certain size font, so these size fonts. And again, you might just think, oh, I'll take my graph and make it small. But then that hampers your communication because the person can't see your graph. And no, you cannot hide things in appendices. There's no extra pages for appendices. So you need to write well. 12 pages, I think, is the maximum.
Sir Fleming, is there a rule that says the page has to be A4?
No, it could also be letter if you're in the US.
It'd be like A3.
There will be all kinds of rules. They didn't have too many rules for us this year because the IB is not always too prepared. Okay. But they do learn from their mistakes, generally. Sometimes. So they're going to have rules for you next year. Okay, 12 minutes left. Coco, any ideas what you'd want to do?
We shouldn't go over the worksheet.
I know. Going over a worksheet is just a worksheet. I know. I said yes, we can go over the worksheets, but I'm much more interested in your internal assignment, which is 20% of your grade. Right, so I'm going to leave Mr. I think it's Mr. Coffee, Oliver Coffee, Caffery, something like that, with basically where we got up to in the syllabus. So he's going to finish topic 6. You have a test next year. Okay, so there's no problem there. Okay, so I'm not worried about finishing topic 6. I'm worried about your internal assessment. Dina, any ideas?
Something about balance points, like balancing.
Ah, balancing points. Yes, so again, center of mass, different shapes, doing things to it. Coco, you can rock something out with your guitar. Right? Right, so again, try to bring, if you have some outside passion that you can investigate, that is where your personal engagement will really come through. It'll be obvious when you're writing. John Yoon, any ideas? Not yet. Okay. Taegun? Okay, but again, you can't repeat anything. So again, our last ones are things that we've done. So what new thing can you do? What new thing? So maybe you guys want to watch Google cool physics videos. Let's go best physics videos. Yeah, could be. So here's some cool physics tricks. Floating ping pong ball. So how does ping pong ball float? What could you change in that experiment? Got a nice little explanation. So the Bernoulli principle you can investigate. So again, you can be watching YouTube videos for physics Taegun. Imagine that. Oh my god, what's he doing here? So remember the can crush? I think ours is more spectacular, wasn't it? Okay. But maybe just doing it this way, you could change different things. Let's skip ahead to the next. That's not scrubbing so well. When you blow underneath, the paper comes up. How would blowing on top of paper lift it up? Oh, so maybe it's something you can investigate there. Hanging water. Blow harder, Taegun. Come on. No? No, okay. One key thing is you want to get rid of the human element. How can you have things move? Let me jump out of this for 1 second. So something I generally get students to figure out on their own, but since I'm not going to be here to give you some tips, sometimes people they want to like launch something and they're just kind of rolling with their finger. That's totally uncontrolled. So if you ever want to have something launch sideways with a constant, say speed or something, set up something that swings down and hits it, and you always have them the same height, and it'll always go the same. So you can control it. So that's one way to control some kind of launch. Let's go back. Suctionless straw. It doesn't work. No, it doesn't work. Underwater atmosphere. I don't know. So you just. What is that thing? Is it an egg or balloon or some toy? Water stream magnet. So again, it was hanging down on the string and it came over. And it's pulling the water over. Okay. So if you're looking for inspiration, Derek from Versatium. 10 crazy science things you can do at home. Right? Watch some YouTube physics videos and you might get some cool ideas. Wait, here's the mask for you. Why some
Work. Now.
Putting each index finger at opposite ends of the cane, and then moving your index fingers in towards the middle. What you find is that they always end up right under the center of mass of the cane. You can try starting off asymmetrically, and they will still end up under the center of mass. You can try.
full here. Sorry guys, speakers are bad now.
Or really fast. Still end up perfectly under the center of mass. How does this work? Number 2, the phone. Have you ever tried to spin your phone? If you do it in this direction, it's pretty easy. It stays a nice thin line. If you spin it along its short axis, you'll also find it spins very well. But if you try to put your phone end over end like this, you can't do it cleanly. The phone will never flip simply end over end without also rotating from one to the other. Instability stroke until the phone rotates around the other axis. Why can't you? Number 3, you've probably seen that if you drop a phone on your hair, you can make it electrically charged. And if you get close to it, now, usually this is very easy because the chemistry textbooks is polar nature of water. Water is a molecule with a positive sign and a negative sign. So what happens is, so we hold this water molecule on the positive side of the water faces the negative side of the cup, and that is what attracts the water to the cup. This is not the real negative. If you have a uniform electric field, there's an equal force pulling the positive side towards it as there is the negative side away from it. So you find that basically do more than just the current molecule. You need a really, really strong gradient in your electric field.
Yeah, so what you learn is wrong.
Basically, not going to happen from the top. So why
So Dina, what's your plan to bring the chemistry, the physics book back? You remember without a reminder?
cereal?
Put a reminder, please.
Then, using a very strong magnet, try to pull cereal as So why is cereal
I'm not sure why my sound is so bad, guys. Anyways, think about ideas over the summer, right? Have some idea when you come back. Remember, this is where 20% of your grade is something that you just want to get done. The longer you go, the more stress it will constantly be hanging over you. And at the end, it will be painful because you'll have internal assessments due in every class. Because there's a final deadline. So deadlines in school don't matter until they matter at the end. And you're going to find out in grade 12, deadlines will start to matter. So we trained you poorly, and then deadlines will come. I got it, yes, yes.
근데 나 이성이랑 결혼하면 공부 안 해도 이성이랑 결혼하면 아니지 결혼할 사람 많은데
And Ryan, goodbye.